Good morning, students. Today we discuss on transformer. Okay, let us see what is transformer. Why do we need a transformer? Then its construction. Okay, transformer is a static device. It can transfer the electrical energy from one circuit to another circuit, but without changing the frequency. While transforming, the voltage will be increased or decrease. Okay. Let us say V1 is the supply voltage, V2 is the load selectivity. So, if you want to increase the voltage or decrease the voltage, so transformer is a static device. It can transfer the electrical energy from one circuit to another circuit without changing frequency, but voltage can be vary, increase or decrease. Okay. So, first let us see why do you need a transformer? In outside you can see here, transformer is the heart of the power system actually. So normally the generating station voltage will be generated at 11 kV, at the receiving station in residential or industry 230 or 440 voltage kV. So it is not possible to generate 230 or 440. Normally they will generate in 11 kV and step up and send to the transmission line and comes to our residential area. There is a substation will be that again step down and transfer to our industry area or house area. That's why whenever we need a step up or step down voltage, we need a transformer. That's why transformer is a part of the power system. Okay, let us see the construction of the transformer. Okay, this is a simple construction of the transformer. So it consists two electrical circuits. These electrical circuits are isolated and they are linked with a common magnetic circuit. Here the source electrical energy fed from one side is called the primary winding, and the electrical energy will take is called secondary winding. Here, so N1 is the number of turns in the primary winding, N2 is the number of turns in the secondary winding. Okay, I1 is the current which is flowing on the primary side, and I2 is the current which is flowing on the secondary side. Okay, E1 is the induced EMF in primary, E2 is the induced EMF in secondary. This is a common magnetic. This is classical. This is simple construction. Now let us see how it works actually. When we excite the primary side by applying AC voltage V1, the primary current I1 will circulate. Whenever the I1 current circulates here, so flux will produce actually. Because of this flux, there is an induced EMF E1. This flux linked with both primary and secondary. Okay, actually, basically transformer works on the principle of electromagnetic induction, mutual induction between two coils. Here, the flux produces I1, primary side. This flux will link with the secondary side of the window. Because of linking the flux, there will be a E2dt. So, like that. Here, N1 is the number of turns in primary, N2 is the number of turns in secondary. Okay. Now, how do we calculate E1 and E2? So, E1 is the minus N1 d phi by dt. N1 is the number of turns in the primary, d phi by dt is the change of flux actually. So E1 depends on the number of turns and flux changes. Next, what is E2? E2 is the number of turns in the secondary, flux change is d phi by dt. So here we know that E1 by E2 equals N1 by N2. Then V1 by V2 equals N2 by N2. So V2 is V1 times of N2 by N1. Okay. Now then we can write that K equals N2 by N1. That's what V2 by N1. K is the transformation ratio. Here, if the K value is greater than 1, K value is greater than 1, then V2 is greater than 1. If V2 is greater than V1, that is called step-up transformer. If K is less than 1, then V1 is less than V2. That is called step-down transformer. So here we can vary the transformer voltage that depending on the number of turns in N1 and N2. So if you want to step up the voltage, number of turns in N2 should be more. By varying the number of turns in N1 and N2, we can step up or step down. Like that to then if you connect the load across this here, then I2 current will flow here. So we will draw the V2. Like that. So the applied voltage in the primary is V1. Then you can draw the voltage V2. This is the basic principle of working principle of transformer. There are two types of transformer. Normally, one is the core type transformer and another is the cell type transformer. Okay, if the construction is cell type, in core type transformer, here core is surrounded by winding. This is the V1 is the primary winding, V2 is the secondary. These windings are winding opposite ends of the transformer. Then cell type transformer, here the windings are being on the central link. This is the primary winding, this is the secondary winding. This is the V1, this is the V2. Depending on the construction, we are going to classify cell type core type transformer or cell type transformer.